Hey everybody, so in this video we're going to look at some more algebra, mainly how we add and subtract like expressions. So a key word that I want to draw your attention to here is the word like. So we don't just add and subtract expressions, we can only add and subtract certain types of expressions, and they're expressions that are like each other, so ones that look similar. So an example of this would be apples and bananas. So an example of this would be if we had 5 apples and 3 apples. Because they're similar types of things, we can add them together. So where 5 apples plus 3 apples will give us 8 apples. So we could say we have 8 apples there altogether if we had 5 apples plus 3 apples. And what we couldn't do is add, for example, our 5 apples plus 3 bananas. Because at the end of the day, when we add these two together, we aren't going to have 8 of some new thing. We're just going to have 5 apples and 3 bananas. So it'll equal to 5 apples and 3 bananas all together. Again, because they're not like, or they're not similar things we're adding together, we can't actually simplify what we're doing, right? But with 5 apples plus 3 apples, it just simplifies down. We get 8 apples all together, right? So even though there's 8 things in both of these, when they're the same thing, we're able to add them and simplify it nicely like that. So now let's look at a slightly more complicated example. So here we've got 5 apples plus 3 bananas plus 2 apples plus 1 banana, right? So we've got 2 different terms that have apples in them, 2 different terms that have bananas in them, right? So like before, we can add apples with apples. So if we add the apples and the other apples, well, all together now, 5 apples plus 2 apples, that's going to give us 7 apples. When we add our bananas, we're going to have 4 bananas. So 7 apples, because 5 apples plus 2 apples gives us 7 apples. And 4 bananas, because 3 bananas plus 1 banana gives us 4 bananas altogether. So we can see this visualized here. Our 5 apples plus 2 apples gives us 1, 2, 3, 4, 5, 6, 7 apples altogether. 3 bananas plus 1 banana gives us 4 bananas altogether. Now, sometimes people make the mistake of trying to add, say there are 7 apples plus 4 bananas, and they get something like 11 apple bananas or something, right? Where they might just say there's 11 apples there or 11 bananas. But just remember that if they are different types of things, they can't be added together or subtracted from one another. So if we look now at how this applies to algebra, we can try adding together variables. So for example, x plus x is like saying an apple plus an apple. We'd have 2 apples, or 2x. X plus x is 2x. Whereas if we tried to add x plus y, well, we actually can't simplify that anymore. It's like trying to add our 5 apples plus 4 bananas, right? They just don't really go together. So we can't make it seem any simpler than that. We can't create something new that's 2 apple bananas. It just doesn't work like that, right? So x plus y, because the terms are different, we can't add or subtract them with each other. So we just leave them like this. They're already as simple as they can be. Let's look at another example here. We have 3x plus x. Well, the terms here are similar because they're both x's. It's like saying they're both apples. So we can add these together. Might be kind of weird for you guys to just see the term x there by itself, because when we're dealing with apples, we'd say 3 apples plus 1 apple, right? But if you just see an x by itself, you can imagine the number 1 being there, right? It's like saying 3 x's plus 1 x, right? But we just don't normally write the number in front of it if the number is 1, right? So x just means the exact same thing as 1x, right? It's kind of there in our imaginations, but we don't actually write it out. So 3x's plus 1x, or 3x plus x, well, we'd have 4 x's there altogether. Just like if we added 3 apples plus 1 apple, we'd have 4 apples altogether. And we can try another example now with subtraction. So let's say we have 15b take away 4b. Right, these terms are the same. So it's like having bananas and bananas or peaches and peaches. Because they each have b um, as their variable, we can add and subtract them like the apples with apples or bananas with bananas. So if we had 15 bananas and we took away 4 bananas, think about how many bananas we'd have left. We'd have 11 bananas. So we can just, add and subtract the numbers like normal, as if they were bananas or apples or oranges or whatever, right? 15 take away 4 gives us 11. Then make sure you keep that variable b to say it's 11 of what? 11 b's. So now what we're going to do is we're going to go look at a question that's kind of similar to the last question we looked at with the apples and bananas. So we're going to have 4x plus 6y plus 3x minus 2y. So you can see here we have terms that have x's in them. We have terms that have y in them. Just like before, we had terms that had apples in them, terms that had bananas in them. So we can add and subtract our x's with each other, and we can add and subtract the y's with each other. But we'll just be left with something at the end that has two different types of numbers in it. So it would be, for example, like before, we had 7 apples plus 4 bananas left over at the end, right? We'll have a certain amount of x's and we'll have a certain amount of y's at the end. So the first step that I like to do here is what I've already just done. I've underlined like terms in the same color. So I've underlined my x's in red. I've underlined my y terms in green. If you do not have different colored pens, some people like to draw boxes around one type. So for example, they might draw a box around the y's and they might draw triangles around the x's. So that's another method that some people like to use. Once you've done enough of these, you may not need to do it that way. But it can be helpful to keep track of which terms can be added with other ones. The next thing I do now is I'd rewrite this, just putting my x's together and putting my y's together. So any terms that can be added and subtracted with each other, just going to put them next to each other. So my 4x plus my 3x are going to go next to each other. And my 6y and my minus 2y are going to go next to each other. I'm just going to color code these again so you can see what I've done. I've moved the red terms or the x terms next to each other. And I've moved the green terms or the y terms next to each other. Now, just like before, I can add my apples and apples, or my x's and x's, and then I can add my bananas and bananas, or my y's and y's, right? So 4x plus 3x gives us 7x altogether. Again, we can add these because they're x's. And then 6y, take away 2y, is just like saying 6 bananas, take away 2 bananas. You're left with 4 bananas or 4y in this case. Now at this point, we've got x's and we've got y's, but these are not like terms, so we aren't going to even try and add and subtract these, right? Because it would be like having 7 bananas and 4 apples and trying to add them with each other, right? You can't end up with 11 apple bananas, so we're not going to try and make the same mistake with our different algebra terms. So we leave the question as it is here. We can't simplify this anymore, right? We have 7 x's and we have 4 y's, but we don't need to do anything with them. That's as simple as it can be. Right, so the last example we'll look at is going to be kind of similar to those ones before. But there's just going to be 1 or 2 little twists in it to try and help you get used to some harder questions. So here we've got a term where the variable is a. Then we've got an a squared term. Then we've got a minus 5a. And then we've got another a squared term. So you can remember that whenever we see just like an a squared by itself, we can imagine that the number there is 1 in front of it, right? It's like the way that if I asked you for what you had for lunch, you might say, well, I had a sandwich. You wouldn't necessarily say, I have 1 sandwich, you know? So we don't need to say the number. If the number isn't there, we assume that it's 1a squared. So with this thing, right, you might be tempted to try and add and subtract everything with each other because you see a lot of a's, But a's can be added with a's or subtracted, and a squareds can be added or subtracted with a squareds, right? So it's just like if we had a's and b's, the a's can't mix with the a squareds when we're adding and subtracting. So what we're going to do, as before, I like to underline similar terms. So my a's are underlined here in green, and my a squareds are underlined in red. And the first step is to rearrange it so that the a's are together, my like terms, and then my other like terms, the a squareds, are together. All right, now I'm going to try and simplify so I can add and subtract my green terms, add and subtract my red terms. If I have two a's and I take away five a's, if you have two of anything and you take away five, you're going to end up with -3 of that thing. So it's like if you have €2 in your account and you take away €5, you end up with -3 €. This is just going to follow the same rules as we've been using earlier on for positive and negative numbers. To take away 5 is -3, right? If the signs are different, you find the difference between them and keep the sign of the bigger number. Or whatever other rule you may have used, if you picked one up already that works for you. And then for our a squareds, well, if we have an a squared and we add another a squared, we're going to have two a squareds. Just like if you had a apple and you added another apple, you'd have two apples. Now again, a's and a squareds cannot be added with each other because they're not like terms, right? The a is different to the a squared. So at this point we'll leave it, right? It's like saying we have -3 bananas and we have 2 apples. Right? We don't start trying to add the apples and the bananas.